form of an angle in radians. All right, so we've done standard form of an angle in degrees. We talked about how the initial side of the angle is on the positive x-axis, and that positive angles move in the counterclockwise motion, and that negative angles move in the clockwise motion. We also talked about these very special angles here on the unit circle. I want to point out a few things here. A few things. Green, that's a good one here. All right, so you'll notice the angles that turn out to be pi over 3 angles, right? This guy is pi over 3, there's 3, right? The 3 in the denominators, right? Those ones closest to the y-axis, and then the denominators get bigger as they go down here. Right here, the pi over 4s, those are always right in the middle. And the pi over 6s are the ones closest to the x-axis. For me, I think about this, I know that over 6 is going to be smaller pieces than over 3. So that's, I think about this distance right here being smaller than the distance from here to here or here to here, because 1/3 is a bigger number than 1/6. However you memorize it, you do need to memorize it. You need to memorize these locations, that the ones that are closest to the y-axis, those are pi over 3. The middle ones, those are pi over 4s. And the ones closest to the x-axis, those are the pi over 6s. All right, it'll help, I promise. So let's draw some angles in standard position. We'll start with -7 pi over 3. Here I've already drawn its initial side. And we're going in the negative direction here. And we see that the denominator is 3. So I'm going to highlight those pi over 3s. That's these guys here. We're going in the negative direction. So I want to remind you really quickly of a rule that we talked about earlier. I have it conveniently on paste here. The way that we work our way around the unit circle and these special angles, if you're going in the positive direction, in quadrant 1, the numerator is just pi. In quadrant 2, the numerator is 1 less than the denominator. So 2 is 1 less than 3, 3 is 1 less than 4, 5 is 1 less than 6. Quadrant 3, the numerator is 1 more than the denominator. So 7 is 1 more than 6, 5 is 1 more than 4, 4 is 1 more than 3. And over here, the numerator is 1 less than twice the denominator. 6 times 2 is 12, minus 1 is 11. 4 times 2 is 8, minus 1 is 7. 3 times 2 is 6, minus 1 is 5. This works the same in the negative direction. It's that same progression. It's just, it goes the opposite direction and the angles are negative. So I'm going to start counting those angles is what I'm going to do. We have negative pi over 3. The next one will be negative 2 pi over 3. And if you really wanted right here, you could just split it up into pi over 3s completely, and you could say negative 3 pi over 3. We know that this is really supposed to be negative pi, but negative 3 pi over 3. Negative 4 pi over 3. Negative 5 pi over 3. Negative 6 pi over 3. That makes sense? Negative 2 pi, it's gone one entire revolution backwards. And this angle here, negative pi over 3, is the same thing as negative 7 pi over 3. So it can help to just split that whole circle up into, if you look at the denominator, the denominator tells you how many pieces 1/2 of the circle should be split into. If you want to perfectly portion it up so you can just count, right? Pi over 3, 2 pi over 3, 3 pi over 3. But notice that they follow the same format. 1 in the numerator, 1 less than the denominator, 1 more than the denominator, 1 less than twice the denominator. All right, so negative 7 pi over 3. Anyway, it lands on this spoke, and that's the really important thing. I can really just delete everything here. And truly everything. Don't need you. Oh. Strange. Delete used to be in a nicer defined place. All right. Negative 7 pi over 3. It's right there. So we know that this angle is first going to go an entire revolution negatively. And then, nope, stop. An entire revolution negatively, and then stops right there on negative 7 pi over 3. 29 pi over 6. We can truly do this. We can really split this whole thing up. It's over 6. So if we wanted to split the whole half circle into 6 pieces, then extend those lines over, we would have ourselves perfectly portioned out pi over 6. Pi over 6 pi, I suppose. All right, there it is. So 29 pi over 6. If we wanted to do this really tedious way, we could say we have pi over 6, 2 pi over 6, which is actually pi over 3. Oops, what am I doing? I'm going backwards. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, right? And I could count this all out, but like you see what's happening, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That would be one entire rotation. I'll mark that. We have at least one entire rotation. That makes 12. 13 pi over 6, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That's another. That's 24 pi over 6, 25, 26, 27, 28, 29, all the way to here. And this is really on the 5 pi over 6 spoke. Now let me we'll put we'll just make it up. There it is. 29 pi over 6. Negative 21 pi over 4. Well, we're looking at those pi over 4 angles. We can split half of a circle into 4 splices. And we're going in the backwards direction. So this would be negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, and so on. And we need to do that all the way to negative 21 pi over 4. So I'm going to start counting. So negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. So that's one full rotation. Negative direction. That would be negative 8, negative 9, negative 10, negative 11, negative 12, negative 13, negative 14, negative 15, negative 16, negative 7, 16 right here. Negative 16 would be another full revolution. Negative 17, negative 18, negative 19, negative 20, negative 21 right here. Boom. So it does 2 full revolutions in the backwards direction and then comes all the way up to here, which is, if you're looking at it as a negative angle, this is negative 5 pi over 4. Just from here to here would be negative 5 pi over 4. Or from here to here would be 3 pi over 4. But anyways, that's how it works. Hope that helped a little bit, and I will see you in the next video to talk about coterminal angles. All right, bye.